mass transfer.
Sounds boring?
Wrong. It's cool.
What is it, you ask?
It's the transfer of mass and energy.
There are two ways to do it. One is
conduction.
That's when heat energy travels through a solid without the material itself moving. That's an example of conduction.
Don't touch a stove.
Disclaimer. We also have something called
radiation.
That's when heat energy travels through electromagnetic waves like light. Hey there, Mr. Sun.
Thanks for the warmth you give.
And last we have
convection.
That's when heat energy travels through motion of a fluid. Watch out for hot water. That's
convection.
Now that we know the basics,
let's get deep. Convection
includes both the bulk transfer of fluid as well as its
random motion.
Near the wall, it behaves like conduction, but far from wall, it behaves like fluid exchange. There are two types of convection. One is
free, and the other one is forced.
Don't force people. It can happen in liquids and gases.
Fluids.
Yes, it's related to fluid mechanics, specifically
fluid dynamics.
It is driven by differences in temperature, pressure, and density. More bulk flow in a system means more heat transfer in a system. Any instant large numbers of molecules are moving collectively or as aggregates. A consequence of fluid surface interactions is the development of a region in the fluid through which the velocity varies from zero at the surface to finite value associated with the flow. This region of fluid is known as the
boundary layer.
If the surface and flow temperatures differ, there will be a region of fluid through which the temperature varies from surface temperature at y0 to flow temperature in the outer flow. The heat contribution of random molecular motion is dominant near the surface where the fluid velocity is low. In fact, at the interface between the surface and fluid, the fluid velocity is zero, and heat is transferred by this mechanism only, very similar to what conduction is, which technically makes convection conduction, but doesn't make conduction convection. But if convection is conduction, then does that make conduction convection at certain scenarios where the velocity is zero?
It's complicated.
I want to talk about aerospace systems.
What are those?
They're the systems used in aerospace.
What are those?
Aerospace involves everything in space and aero.
What are those? Gas turbine engines.
How is it related to heat and mass transfer, you ask?
Fluid systems.
They are composed of pipes and channels that hold a fluid called
coolant.
Ideal coolants would have a
high thermal capacity.
That means it would be able to take in a high amount of energy before it goes up by 1 degree. Examples include air, fuel, water, and
ethylene glycol.
They suck.
Correct.
They suck the heat energy through physical contact of pipe to the hot parts, thus
conduction.
Then from within the pipes and channels, a
cool liquid
goes very fast and sucks the heat away from the pipe holes. That's
convection.
But where's the mass?
mass is in the fluid.
Specifically, the particles that contain that heat energy are now transferred to another place away from the
Important parts.
by